Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first part of Indices and Surd, where we have learned the laws of Indices and Surd, what are pure and mixed surd, what is rationalization, and so on. So if you haven't gone through that video till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to see some problems based on indices and surds. So let us start with today's video. Let us start with the simplification of these two expressions using the laws of indices. Before seeing the solution, I would request you all to solve these questions from your end first and then to check the solution. The first one given is 10 raised to power 5 to the power 4 times of 10 raised to power 3 to the power 4 divided by 10 raised to power 6 to the power 4. So here, if we simply use the rule of indices, a raised to power m to the power n equals a raised to power mn, and a raised to power m times of a raised to power n equals to a raised to power m plus n, and a raised to power m upon a raised to power n equals a raised to power m minus n. In that case, this expression will become 10 raised to power 20 times of 10 raised to power 12 divided by 10 raised to power 24. So again, if we simplify this, this would be 10 raised to power 20 plus 12 divided by 10 raised to power 24. So this would be 10 raised to power 32 divided by 10 raised to power 24, which would be 10 raised to power 32 minus 24, which would be 10 raised to power 8. So if we simplify this expression, this would be simply 10 raised to power 8. Now, if we come to this expression, and if we again apply the rule of indices, in that case, this will be 3 raised to power 8 times of 9 can be written as 3 square, and there is a power 6. So this will become 3 raised to power 2 into 6, that is 12, divided by 27 square. Now 27 can be written as 3 cube, and there is a power 2. So this will become 3 raised to power 3 into 2, that is 6. And there is a under root. So again, if we simplify this, this would be 3 raised to power 8 plus 12 minus 6, and there would be under root. So this would be 3 raised to power 20 minus 6, that would be 3 raised to power 14, and there is an under root. So this will become 3 raised to power 14 to the power 1 by 2, which would be 3 raised to power 7. So if we simplify this expression, this would be equal to 3 raised to power 7. Now let us solve this two equation for x. So if we start with the first one, it has been given as 34 raised to power 4 equals 17 raised to power 4 times of 4 raised to power x. We need to find the value of x here. We know that 34 can be written as 2 times of 17. So this can be written as 2 times of 17 raised to power 4 equals 17 raised to power 4 times of 4 raised to power x. So using the rule of indices, this can be broken down as 2 raised to power 4 times of 17 raised to power 4 equals 17 raised to power 4 times of 4 raised to power x. Now 17 raised to power 4 and 17 raised to power 4 can be cancelled from both sides. So this would be 4 raised to power x equals 2 raised to power 4. Again, 4 can be written as 2 raised to power 2x equals 2 raised to power 4. Now, if we use the rule of indices, a raised to power m equals a raised to power n. In that case, m would be equal to n. So here, 2 raised to power 2x is equal to 2 raised to power 4. So we can write 2x would be equal to 4. So the value of x would be 4 by 2, that is 2. Now, if we come to the second one, here 1 by 5 raised to power 20 divided by 1 by 25 raised to power 4 equals 5 raised to power x. So here we can see that here we have 5 in the denominator, here we have 25, and here we have 5. So let us try to convert 25 in terms of 5. So this would be 1 by 5 raised to power 20 divided by 1 by 5 square raised to power 4 equals 5 raised to power x. So again, this would be 1 by 5 raised to power 20 divided by 1 by 5 raised to power 8, simply by using the rule of indices, equals 5 raised to power x. So this can be written as 5 raised to power minus 20 divided by 5 raised to power minus 8, which would be equal to 5 raised to power x. So again, here the bases are same. So this would be 5 raised to power minus 20 minus of minus 8 equals 5 raised to power x. So this would be 5 raised to power x equals 5 raised to power minus 12, which will give us the value of x to be minus 12. So we are simply using the laws of indices to get the value of x. Well, if you're unable to get these problems, I would suggest you to go through the first video once again, where we have discussed about the laws of indices and surds, and then come back to this problem, because in that case, you'd be able to understand these problems easily. Now, let us see this sum where we need to find m and n, where 3 raised to power 12 times of 6 raised to power 8 is equal to 3 raised to power m times of 4 raised to power n. So here we have 3, 6, and 4. So let us try to break 6 in terms of 2 and 3 and write 4 in terms of higher powers of 2. So in that case, this can be written as 3 raised to power 12 times of 2 raised to power 8 times of 3 raised to power 8, as 6 is equal to 2 times of 3. And this would be equal to 3 raised to power m times of 2 raised to power 2n, because 4 is 2 square. So here again, if we simply use the rule of indices, so this would be 2 raised to power 8 times of 3 raised to power 12 plus 8, which would be 3 raised to power 20, and this would be equal to 3 raised to power m times of 2 raised to power 2n. Now, if we compare the left hand side and the right hand side, in that case, this 2 raised to power 8 will have to be equal to 2 raised to power 2n. So in that case, 2n would be equal to 8. So the value of n from here would be 4. In a similar way, 3 raised to power 20 has to be equal to 3 raised to power m. So the value of m has to be 20. So m is 20. So the value of m is 20 and the value of n is 4. Now let us simplify this surd. So we have been given a surd and we need to simplify this, and we can see that there are irrational numbers in the denominator. So whenever we have irrational number in the denominator, the first thing we need to do is simply rationalization. Rationalization we have already covered in the first part of indices and surds. So I would suggest you to watch the first part of indices and surds and then to come back to this problem. So here, if we do the rationalization of these 3 fractions, to simplify, in that case, this would be 6 times of 2 root 3 plus root 6 upon 2 root 3 minus root 6 times of 2 root 3 plus root 6. In a similar way, this would be root 6 times of root 3 minus root 2 upon root 3 plus root 2 times of root 3 minus root 2. And this would be 4 root 3 times of root 2 plus root 6 upon root 2 minus root 6 times of root 2 plus root 6. So what we're doing is we are simply rationalizing the denominator, where we are multiplying the conjugate of denominator in the numerator and denominator of each fraction. So if we simplify this, this would be 6 times of 2 root 3 plus root 6. And the denominator will become a minus b, a plus b form. So this would be a square minus b square. So this would be 2 root 3 square minus root 6 square. And this would be root 6 times of root 3 minus root 2 upon root 3 square minus root 2 square. And this would be 4 root 3 times of root 2 plus root 6 upon root 2 square minus root 6 square. Now, if we further simplify this, this would be 6 times of 2 root 3 plus root 6. And in the denominator, this would be a square minus b square. So 2 root 3 square would be 4 into 3, that is 12. And root 6 square would be 6. So 12 minus 6, that would be 6. Plus, this would be root 6 into root 3, which can be written as 3 root 2, because root 6 is root 2 times of root 3. So this will become 3 root 2 minus root 6 into root 2, that will become 2 root 3 upon root 3 whole square, that would be 3, minus root 2 whole square, that would be 2. So 3 minus 2, that would be 1. Plus this would be 4 root 6 plus 4 root 3 times of root 6. So that would be 4 root 3 times of root 2 into root 3. So that would be 4 into 3 times of root 2. So that would be 12 root 2. And in the denominator, this would be root 2 square, that is 2, minus root 6 square, that is 6. So 2 minus 6, that would be minus 4. So again, if you simplify this, this would be 2 root 3 plus of root 6 plus 3 root 2 minus 2 root 3. And here we can cancel 4 from the numerator and denominator. So this would become minus root 6 minus 3 root 2. Now, if we see, we can cancel this 2 root 3 and minus 2 root 3, this plus root 6 minus root 6, this plus 3 root 2 and minus 3 root 2. So the answer would be 0. So when we simplify this third, this would be equal to 0. Now, let us see this question. Find the value of x if x minus root 24 times of root 75 plus root 50 upon root 75 minus root 50 equals 1. So we can see here there are surds involved and we need to find the value of x. So here root 75, root 50, so these are all pure surds. So first let us convert these pure surds into mixed surd. So root 75 can be written as root of 25 times of 3, which can be written as 5 root 3. And root 50 can be written as root of 25 times of 2, which would be equivalent to 5 root 2. So if we simply replace this pure surd by its mixed surd, in that case, this would be x minus root 24 times of 5 root 3 plus 5 root 2 upon 5 root 3 minus 5 root 2, and this is equal to 1. Now we can cancel 5 from the numerator and from the denominator. So this would be x minus root 24 times of root 3 plus root 2 upon root 3 minus root 2 equal to 1. So from here, x minus root 24 can be written as root 3 minus root 2 upon root 3 plus root 2. So again, if we rationalize this, this would be root 3 minus root 2 times of root 3 minus root 2 upon root 3 whole square minus root 2 whole square. So in the numerator, this would be root 3 minus root 2 whole square. And in the denominator, this would be 3 minus 2, that is 1. Now, if we simply use the formula of a minus b whole square, in that case, this would be root 3 whole square, that would be 3, plus root 2 whole square, that would be 2, minus 2 into root 3 into root 2, that would be 2 root 6. So this would be equal to 5 minus 2 root 6. So finally, we can say that x minus root 24 is equal to 5 minus 2 root 6, or x minus root 24 equal to 5 minus this 2 root 6 is in mixed surd, so we can convert this into pure surd by taking 2 inside the root. In that case, this would be 6 times of 2 square. So finally, this would be x minus root of 24 equals 5 minus root of 6 into 4, that is 24. So we can cancel this root 24 from the left hand side and right hand side. So the value of x comes to be 5. So Simply by converting pure surd into mixed surd and rationalization, we can find the value of x. Now, let us see this question. We need to find the value of root x plus 1 upon root x, where x is a surd, which is equal to 7 plus 4 root 3. So to find the value of root x plus 1 upon root x, first we need to find the square root of x. So the square root of a surd can be found out simply by writing the surd in terms of a square plus b square plus 2ab or minus 2ab form, because a plus b whole square is equal to a square plus 2ab plus b square, and a minus b whole square is equal to a square minus 2ab plus b square. So here x is 7 plus 4 root 3. So if we want to find the square root of x, we need to rearrange the surd in terms of a square plus 2ab plus b square form. So first, let us try to see what can be 2ab from this surd. So this is 7 plus 4 root 3, which can be written as 2 times of root 3. So this can be thought as 2ab. So from here, we can say that our a would be this 2 and our b would be root 3, because 2 square plus root 3 square would be giving us 7. So this 7 can be written as 2 square plus root 3 whole square plus 2 times of root 3. So finally, this will be 2 plus root 3 whole square. So root of x would be simply 2 plus root 3. So now root x plus 1 upon root x can be written as 2 plus root 3 plus 1 upon 2 plus root 3. So here again, we can see an irrational number in the denominator. So we'll be simply rationalizing it. So this would be 2 plus root 3 plus 2 minus root 3. And in the denominator, this would be 2 square minus root 3 whole square. So this would be 2 plus root 3 plus 2 minus root 3 upon 2 square, that would be 4, minus root 3 square, that would be 3. So 4 minus 3, that would be 1. So this would be finally 2 minus root 3. So from here, we can cancel plus root 3 and minus root 3. So this would be 2 plus 2, that would be 4. So the value of root x plus 1 upon root x would be equal to 4 when x is equal to 7 plus 4 root 3. So whenever we need to find the square root of an irrational number, we will try to write the expression in terms of a square plus 2ab plus b square, or a square minus 2ab plus b square, which will give us a plus b whole square or a minus b whole square. In that case, we can find the square root very easily. Now, let us see this question. Which among square root of 2, cube root of 3, fourth root of 4, sixth root of 6, and 12th root of 12 is the largest? Well, here to find the exact value of this surds would be difficult. So we need to find a way by which we can say that out of this 5 surd, which one would be the largest? Well, here we'll be simply using one concept. That is, if a and b are two positive numbers, and if a is greater than b, in that case, the higher powers of a would also be greater than higher powers of b. For example, if I have 2 greater than 1.5, so the higher powers of 2, let us take it to be 2 square, and the higher powers of 1.5, in this case, this would be 1.5 square. So 2 square would also be greater than 1.5 square, as 2 square is 4 and 1.5 square would be 2.25. So if there are two positive numbers in which one is greater than the other, then the higher power of the greater number will also be greater than the higher powers of the smaller number. So we'll be raising this surds to a higher power such that we'll be able to find which among this is the largest. So here we can see in the denominator of powers, we have 2, 3, 4, 6, and 12. So let us take the LCM of this 2, 3, 4, 6, and 12, which comes to be 12. So let us raise these surds to the higher powers of 12. So in that case, this surge would be 2 raised to power 1 by 2 to the power 12, which would be 2 raised to power 6. 3 raised to power 1 by 3 to the power 12 would be 3 raised to power 4. 4 raised to power 1 by 4 to the power 12 would be 4 cube. 6 raised to power 1 by 6 to the power 12 would be 6 square. And 12 raised to power 1 by 12 to the power 12 would be 12 raised to power 1, which would be 12. So 2 raised to power 6 is 64. 3 raised to power 4 is 81. 4 cube is 64. 6 square is 36. And 12 raised to power 1 is 12. From here, we can see that 81 is larger than all these numbers 64, 36, and 12. So the largest among all these surds would be 3 raised to power 1 by 3. So that's our answer. So in such kind of problems where we need to find which one of these surds is the largest, we can simply take the higher power of surds to find the largest. So that's it for today's video, in which we have seen some problems based on indices and surds. But I would request you to practice more problems, because the more you practice, the more you learn. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.